Thank you. Cool thing, if you go to the agenda, then my slides are actually already linked from there. So you can check out what is coming up in a few slides ahead. And we will see when you visit this document. Okay, so somebody was switching on the acronym generator and came up with PhenoMeNal, which is difficult to believe. So I'm Steffen Neumann from the IPD in Halle, and we have both been part of that EU project, but we've also been, or still are, one of the 38-something partners in the de.NBI project. So what we have set out is to bring metabolomics to the cloud. In the old days, people were using mass spectrometry data and analyzing that like by eye. And nowadays we are doing that in a much more high throughput way using XCMS. The CD de.NBI Center is working with OpenMS, and it doesn't really matter, but somehow you get the mass spec raw data into some rectangular matrix. And then there's phenome centers like the one at Imperial College, and they are talking about 24,000 runs per year because that is part of the British health system initiatives to have your metabolome analyzed when you visit a doctor, which may really happen in practice in down the road, but that is what we are aiming for in developing the infrastructure. So who of you has been doing metabolomics at some stage? That is rather few, so I will kind of skip all the details on that, unless you're interested in that. So we have set out to do all of that with Galaxy. That was mentioned briefly today before, and Galaxy is a web-based interface where you have building blocks that you connect to a workflow, and then you have the intermediate results as part of your history that appear here to the right. And we are not the first people to use Galaxy, so if you want to learn more about that, you go to the Galaxy project. There have been people in France using Galaxy for metabolomics before, and there is also a team in Birmingham also using Galaxy for metabolomics. But all of these would be Galaxy installations that are somewhere hosted in France or somewhere else. So if you did have sensitive patient data, you can't just upload all your data to France or whatever. So this is why we have looked at if there's a way to let's say, cloudifying the whole workflow thingies, because once you have everything set up to run on local stack, you can buy a rack preloaded with OpenStack and put that into the basement of the hospital, and the data would never ever leave the hospital, and the IT administration doesn't have to manage all the individual tools and install them, let's say, on the bare metal. So traditionally, Galaxy servers were installed on a big server machine, but we are continuously seeing that they are, the individual tools are put onto containers, and that really is a very good thing against the installation burdens that you have usually. So we wanted to have the tools in a portable way. Spoiler alert, we are talking about containers, scale out, we're talking about clouds, and we want to also support the private clouds. If you look at the European cloud infrastructure landscape, it is really messy out there. Let's say the easy things are, what are the actual, let's say, bare bones cloud infrastructures that we have to talk and care about. Amazon, Google, Microsoft have been mentioned, and OpenStack is what we have in the de.NBI cloud. And then you have the poor bioinformatician, and somehow she wants to connect and bring her stuff into this cloud, and there's a lot of weird stuff in between where some help is needed. There's a lot of EU-related projects and infrastructures, and what PhenoMeNal has set out to bridge is the gap between all of these. So what we wanted to have is a batteries included software stack that you can deploy on any of these. So users should be able to instantiate their own virtual infrastructure on commercial or scientific clouds, private clouds, or even a beefy internal workstation. And we wanted to avoid reinventing the wheel and use those frameworks supported by industry that have a large user base and all the buzzwords that you would usually expect. Now, how would that work in practice? Actually, in my talk, I'm trying to switch between two layers. One would be a user, let's say a person doing a metabolomics experiment, wanting to lift up such an infrastructure, analyze the data. And the other layer that I'm talking about will be more of the backend information. So I'm trying to make sure that you see, if you're a bioinformatician or infrastructure person, which aspects are relevant to you and which are relevant to the users. So the user would be using the browser to go to what we call the PhenoMeNal gateway, which is a web application. Log in via the Elixir AAI. And there you can then select where the infrastructure shall be deployed. So which is your target infrastructure over there. In the backend, there is a cloud portal located at the de.NBI. They're managing software stacks, and we see how that works in a moment. Then there is a tool that is probably similar to what we've heard earlier as Elastic Cluster, or some other ones that are responsible for lifting all the infrastructure, installing all the software on that, and giving you a turnkey-ready cluster, so to speak. Then you have the virtual cluster on these resources, and then you get your Galaxy instance running in this virtual cluster. Okay, very early on, because I was part of the de.NBI thing, I was able to get access to the Bielefeld and Gießen, and now also to Tübingen, where we can deploy the same infrastructure, almost unchanged, with the exception of Tübingen, and then really create a rather complex network, virtual machines, volumes, and all of that, and I can show that in a moment. Now, I haven't seen any live demos today, so maybe there was a So let's see, we go to our portal, then we want to create our own environment. I want to log in via Elixir. I am possibly already logged. No, I was not. The thing is, I logged in and the backend login has expired. So how do I? So I didn't wait long enough so I would get a fresh login page. Ah, there we go. I was impatient. Let's try again. This is the environment. This is why we didn't have the online demo so far. Let's try again. Now I'm getting to my home institute, ready to log in. Yes. So this is now where we can start to select where we want to deploy the thing, and we see that Amazon is supported. So you need an Amazon account there that has a credit card behind it, and then you can deploy to Amazon. Actually, in the early times, getting your institute's or university's credit card would have been the most difficult task on all of that. Google supported, OpenStack is supported, and we also have partner providers where access is free, but you need an account. This one is located in Göttingen. Let's see how we get there. I now need my username and the password. If somebody has a solution for password management, just not trusting the browser for that. So now we can set up the cloud instance. So we need to choose some of the things that you will also get to know when it comes to the OpenStack tutorial tomorrow. So we need to tell that we are connecting to the external network, that we are getting an IP address from the external one, and that we want to use the de.NBI small nodes. And we need to choose a password. I happen to have password handy, which is very secret, so you're allowed to memorize that. Password must contain numbers and letters. It does. Numbers and letters. That is my password. Okay. Let's try something else. Passwords and letters. We'll find something that has password. Let's say.
Perhaps only letters and numbers.
Ah. Let's create a new password then. Up here. So you mean something like that?
Maybe. Sometimes they are picky if it starts with a number instead of a letter.
So let's try again. Now I can review all my settings that I have and start deploying. And I did that because it will take a while. So what's happening now is this was where I tried yesterday, a few days ago, to do that. And now we are doing the same thing. So we are now deploying. We are contacting the OpenStack cluster. We are starting a number of virtual machines. We can actually have that was the other link. Log into GC. So now you can sort of live see what's happening in the background. There you see what would be the benefit of a single sign-on. So this now connects to the de.NBI cloud in. I love this view here. So where you see this is also a sneak preview to tomorrow's thing. That here's the external network, so that's the rest of the world. Then we have a private network where only our virtual machines are connected to that. Here's the first virtual machine that has appeared, which probably is going to be the master. And then if we revisit that, we might see how others are appearing. For the sake of time, we will not watch that live, but you would see other nodes popping up in that bubble here, which I find very fascinating sometimes. Okay, so that was the beginning of the demo. What we're using in here is, you have heard all the buzzwords before. So all the tools that we have are living in GitHub repositories. We are building Docker containers from those. They are sitting either in Docker Hub or a private container repository, and then they are managed by Kubernetes, which is taking care of pulling the images, then running them. If something fails, then another one is restarted, and all of that cluster management. And you'll also see that tomorrow in the Kubernetes hands-on parts. A few more logos, what we are using. So containers managed by Kubernetes. If you're talking about a Kubernetes cluster, there is also some local network, overlay network involved there. And what we can put on that is Galaxy, as we have seen before. Jupyter Notebooks are part of that infrastructure. This is one workflow engine that was not mentioned so far. This is Luigi, coming from, what is Spotify, right? And Pachyderm is another. So there's so many out there. And we are using this cube now, and I'll show a bit of that in a moment, which is using Terraform to do all this talking to OpenStack, or Amazon for that matter, to create all the instances. And yeah, there's also some DNS services involved there. So that altogether is what we call the batteries included application stack. So tomorrow you will learn a bit about the OpenStack. Then Ansible will be mentioned somewhere, and I also saw in the program that Terraform will be mentioned, and of course the biocontainer stuff. I mentioned how we define such an application stack and lifting that, and this goes now to the nerdy, techie parts. So what happens in this Cube Now thing is that there's a directory tree that is sitting in a GitHub repository, and for each of the providers there's a deploy and destroy script, and they're actually very similar to each other, so not too much to do. Then there is some aspect on Terraform that tells us how to create the different nodes. We have seen before that in the web application we can actually choose which flavors we want to boot, if we need large ones or small ones. And then there is two places where Ansible is involved, and that is taking care of installing this Kubernetes, the software packages required for that. And once all the Kubernetes cluster is up and running, then there is another thing, and that is Helm. And Helm you can consider a package manager for groups of containers that are making up an application. So that would be very similar to what we've just seen for Eggnog. That could be described as a Helm installation. Okay, we can do even more demonstration because I have locally one of those cluster definitions. That was where I got my passwords from earlier. So this is what our equivalent to the DB grid definition probably would look like, where we give some information about what are the networks that we want to use in the OpenStack. And in the beginning, I could only use the user UID for that. Maybe nowadays it even works with a human readable network name. Probably, we would have to try that. Then again, we can choose the flavors. We can say we want to have 3 nodes, and that will become important later. We create a cluster file system, so that is within our virtual cluster. We have a set of nodes that are providing a clusterFS storage, which comes then configured. So that could possibly be a way to provision a shared file system within the cluster. But I have to say we also have seen that Postgres does not want to live on that. So that's a place where we need some more experience. And here are different components, and I'm only including Galaxy right here for the sake of time. And then below that there is no user changeable parts down here. And this is actually not written from scratch, but is initiated through a program. And what we are doing now is we are using this Cube Now apply, and this should now start all this deployment process that we have also seen in the portal. So I'm deploying one cluster via the portal. That was a graphical user interface in Gießen. And that is now doing the same task essentially from the command line here in Bielefeld. Okay, when it comes to the Galaxy tools, then we have developed them on GitHub with a total of by now 250 Galaxy modules covering many different parts of the metabolomics tool space, so to speak. And we've created a number of metabolomics workflows. Some of them are on LCMS data. There is something on metadata to describe your experiment. We have seen that was mentioned earlier on. And there are some tools that we have created on metabolite identification, and of course some statistics down there. Since not too many of you are working in metabolomics, I'll spare you the details, like those details. And one of the reasons why I like these workflow environments is because if you're in the Python world or in the R world, then you really are limited to the tools from your universe. When you are in the workflow environments, then you can actually mix and match tools from different universes, so to speak. And that is something where we as a community have to work, that tools also have standard exchange, data exchange formats. And this was also something that we have looked at in this project. Yeah, these would then be from different universes, so we can mix and match, of course. And what we have started to do recently, and Björn will love that slide, is that we have sort of inverted the development model. At the beginning of PhenomeNal, we did everything in our own GitHub repositories. And we are now starting to instead move to Bioconda, so that it's not only possible to include these tools inside PhenomeNal, but also in standard Galaxy installations. So this is something that we should be seeing at some stage. This is a slide I promised for you, and how to make your users actually comply with metadata annotations and stuff. That regardless whether it's metabolomics or not, what you have seen earlier is that people did their experiment, did measure the data somehow, did some data processing, wrote the manuscript, and then saw that they are required to deposit the data somewhere. So they go back to data conversion to open formats, they go back to the lab book to figure out what the heck did I do 2 years ago, and create what we call isotab, which is one way of doing metadata analysis for an experiment, which is extensively used in the metabolomics area, but also in others. It basically tells you about the samples and what assays and what things you have found in there. And what we are proposing for quite a while and evangelizing is make the data annotation aspects, the green or blue boxes, depending on your eye vision, make that integral part, because we have standard operating procedures in the lab, and heck, we should also do them for the data processing parts, and integrate the two, so that when you go through all the data analysis parts at the end, then everything is written in a manuscript and also ready for data reuse in some repository. Do that right from the start and not double the work afterwards. So one example where we have done that was one of these experiments, and the experimentalist has very early in the process uploaded his data set under some accession number long before publication to the EBI data repository. And then we were analyzing that on the PhenomeNal instance, running on de.NBI actually, to create some figures for the manuscript. And we actually got another incentive. 2 publications out of that. One is on the data and the workflow in Scientific Data, which is one of these recent data-centric journals where you describe the data set and the data analysis on top of it, which doesn't need to be rocket science, where other journals will turn you down for the lack of novelty. But this really is about the data. Also quality assurance aspects can be mentioned there. And then we had the actual biological findings in a more specific journal to ecology. And that is what metabolomics data would look at if it's stored at the EBI. And Galaxy would be running and doing its thing, including some statistics on bryophytes or mosses for non-plant people. Are mosses plants? I don't even know. And then there was a scientific data paper that I mentioned, and the real one on the seasonal variation of secondary metabolites in 9 different moss species. In Galaxy, I'm always torn between having a GUI that is very nice to access and on the command line doing things as a programmer would like to. But with Galaxy, you also have an access to a REST interface to Galaxy, so that you can actually run a large number of workflows from the command line. And we did that to reanalyze a large number of these studies that were in the EBI repository, and created some sort of statistical analysis for these. And that's something where then you get the best of both worlds. You have the API access and you have a user or biologist-friendly interface. Scaling was mentioned. I just want to mention that this is embarrassingly parallel programming, so no rocket science and interconnect and network latencies are involved. And basically we tried with up to 1,000 cores, and somewhere we had the time required to lift the whole cluster, possibly on the next. Yes. So deployment on Azure was like 10 minutes, and the whole analysis we had here running on 2,000 spectra with a particular package, and that was down to $10. So that's also the economies of scale compared to buying your own cluster or not having a de.NBI cluster. And that's it for now. I almost kept in time. Afterwards we would have the Galaxy cluster. And yeah, we do have in the slides at the end a number of links. And thanks, of course, go to the whole team that was involved there. And thank you for your attention.